Thanks, Stephen. And thank you, Stuart, for the justifiably cynical introduction. So, geoengineering, what is it? Well, it's a deliberate large-scale intervention in the Earth's natural systems to combat climate change. Is it something we should be doing? No, but we may have to do it, so we need to do the research on it. So we've got a problem with CO2. There's too much of it, and we don't know what to do. Two things with it. One is the temperature rise, and the breadth of the colors there indicates that there's a lot of uncertainty as to what temperature rise you'll get with any particular level of CO2. We might get lucky, but we can't rely on that. The other one is that the sea's getting sick, and too much CO2 leading to ocean acidification, which everybody here knows about because it's Plymouth. So what can we do? Well, the best thing to do is to reduce emissions and use less energy, less carbon-intense energy, and capture the emissions before they get into the atmosphere, what Stuart was recommending. But whilst reducing emissions is necessary, indeed essential, it may not be sufficient. So we may actually need to turn back the clock on climate change. So what Stuart is talking about is slowing down the clock on climate change. We may need to turn it back. So surely prevention is better than a cure, and that is indeed what the Royal Society on their report on geoengineering said. So the best way is to reduce emissions. But if you can't prevent it, you sure need a cure, and here's why. This is a plot from a paper by Jason Lowe. It's a climate model looking at what happens to the level of CO2 in the atmosphere. The black line shows what's projected to happen, and then the colored lines coming off assume that at those points there are zero emissions. So at the point where the green, the blue, and the orange line come off, it is as if all industrial production around the world has ceased completely, and everybody on the planet has died. I'm not recommending this as a policy option. I'm just saying this is what would happen. And what you see is that the level of CO2 in the atmosphere declines, but very slowly. So we're at 390 and a bit parts per million per year. What's the safe level of CO2? Nobody really knows. It's as if we're running towards a minefield. We don't know where the minefield is. It might be 5 miles away. It might be 100 meters away. It might be already in the minefield. But the best thing to do is to stop and retrace our steps. Say it was 350 parts per million, which is the view of 350.org. How long would it take from a complete extinction of human race scenario for the level to fall to that level? 200 years. Okay, and every decade we pump out another 20 parts per million, or increase 20 parts per million in the atmosphere. That's another century going back. So we don't know where the minefield starts, but we certainly need to do something to think about how we get back. So why we may need a cure? This is a comment by Doug Parr, Chief Scientist of Greenpeace. It's an expression of political despair, and I think he's right. But there may be a lack of political will. Stuart, as I said, justifiable cynicism. There may be a lack of technical ability, and we may not be able to scale up the potential solutions to draw CO2 out quickly enough. And the climate may be more sensitive than expected. So what is geoengineering? As I said, deliberate large-scale intervention. And you can think of it as an airbag. It's something you never want to use. It's a pretty unpleasant day if you do. But if you have to, you're grateful you have it. And the time to design it is before you're skidding on the ice. So this is a plot which shows a variety of different techniques, proposed geoengineering techniques from the Royal Society report. Don't know how well you can see it, but you've got a lot of colored dots. Greens are safer. The x-axis is affordability, so further to the right is cheaper, and the y-axis is effectiveness. So what that is saying is the higher up it is, the more effect it has. So afforestation, cheap, safe, but not very effective. You can plant lots of trees, but you won't be able to draw down a significant amount of CO2, a large amount, but not enough to prevent climate change to the extent that we want to. The orange dot in the top right-hand corner is putting particles in the stratosphere. So this is something that we've seen with volcanic eruptions, putting stuff in the atmosphere, bouncing a fraction of the light back into space. And that is something which would be cheap, it would be effective, but it would be probably somewhat dangerous. It would disrupt weather patterns, it might destroy the ozone layer, it would do nothing about ocean acidification, and it would change the color of the sky from being blue, become kind of whitish. So there are a wide variety of different techniques, and I'll come on to a few of them in a second. So there are two main flavors. So the one about the aerosols in the stratosphere is known as solar radiation management. It's bouncing a bit of light back into space. This cools the climate. It seems that this would be relatively cheap to implement. That's not to say the side effects would be cheap, but to implement it would be cheap. And this would be a way of cooling the planet. But it would do nothing about the level of CO2, and so it would actually accelerate the rate of ocean acidification. You have a cooler planet with the same level of CO2 means more drawdown of CO2 into the surface waters. So it's not a complete solution. Carbon dioxide removal is treating the symptom itself and curing it, but it is likely to be very slow, more expensive, but inherently it would probably be safer, although these are very difficult terms to look at. So just having a quick look at some of them, particularly around the ocean. Ocean fertilization you'll be familiar with. This is adding nutrients to the ocean in areas which are deficient in those nutrients to encourage growth of algae and drawdown of CO2. That has limited potential. It could draw down CO2, and we've seen various papers on that to say that that could happen, but it is quite limited in what it can do. Other marine things include, there's a dot there which says enhanced weathering, and there's something called ocean alkalinity. This is about putting alkaline materials into the ocean. That increases the pH, it enhances the chemical capacity of the ocean to draw down CO2. Very little work or research has been done on that to understand it. There are ways in which you can combine some of these techniques. So Jonas earlier talked about BECCS, biomass energy and carbon storage. You can combine this with enhanced weathering and draw CO2 down that way. How am I doing for time? 5. Okay. So there are plenty of risks involved in geoengineering research. There are obviously environmental risks. So we can think of those very obviously. You get it wrong, you're putting iron or lime in the ocean, you can think that that might not be a particularly good idea. It may have benefits, but it could also have severe consequences. So we need to research those. There are also social risks. So if we undertake this kind of research, there is a risk that people will say, well, we don't need to worry about cutting emissions. And this is what's known as the moral hazard risk. You've also got risks of lock-in of certain technology or research that people are doing. So this is something that we need to be very aware of. And then there are knowledge risks, and these come in two flavors. One is not enough knowledge. So imagine the situation that you're in 20 years' time, and research has not been undertaken in geoengineering. And some climate catastrophe happens, and policymakers are pushing, we need to do something. Which button do we press? And what can happen is that if you don't have the information, you can make some existentially bad decisions. So you might have a technology which you think is safe, but because you haven't done the research, is not safe, and you press that button and it has disastrous consequences. Or conversely, you may have a technology that is safe, you haven't done the research, and you daren't press the button because you don't know what's going to happen, and so you suffer the consequences of not being able to use that cure, as it were. So those are knowledge risks of not enough, and you've also got the knowledge risk of too much knowledge. If policymakers think that they have an almost solution, then they'll go, well, let's not worry about cutting emissions, and they might implement something against the wishes of the scientific community, which wouldn't be the first time that has happened. So there are many risks associated with geoengineering research. I'm going to skip this. Just to say, mitigating the risks, we need to conduct research. We also need appropriate governance to ensure that we do the research in the right way. And we need responsible messaging. And what do I mean by this? Well, I'll give you an example of irresponsible messaging. This gentleman is Newt Gingrich. I use the term gentleman anyway. He said, geoengineering holds forth the promise of addressing global warming concerns for a few $1 billion a year. Bring on American ingenuity, stop the green pig. This is just wrong. And it's doubly wrong. It's wrong because it's factually wrong, because while the implementation costs of some proposed techniques might appear to be low, the side effects are unknown, and it's not a complete solution. It's also morally wrong. It's implying to people that they do not need to reduce emissions because there might be a way to reduce climate change, and that's irresponsible. So we need to make sure we get that messaging right. So what are we doing in Oxford? The Oxford Geoengineering Programme is part of the Oxford Martin School that addresses the challenges of the 21st century. And it does so by working in an interdisciplinary way with people from a variety of different disciplines. These are all professors of their various different disciplines. And the programme advocates research into geoengineering, but it does not advocate geoengineering itself because we don't know if it is safe enough to do any of them. It's interdisciplinary and collaborative, and we do a lot about engagement and communication. We're developing a route map of what research should be done, and we're conducting research itself. One of the things we've been looking at is the governance of geoengineering, and an early piece of work that we did, which was adopted by the British government, is something called the Oxford Principles, which are draft principles for the conduct of geoengineering research, which two colleagues from Oxford and one from UCL and one from Cardiff and myself wrote. And these are 5 principles really to say geoengineering should be regulated as a public good. That's to say we can involve the private sector, but we should be very wary as to how we do so as to avoid negative consequences. We need public participation in decision making. We can't afford to repeat the mistakes of GM crops or of nuclear power, and apart from doing so for such instrumental reasons, it's the right thing to do, and you get better answers by involving the public in decision making. We need to disclose what research we're doing, and we need to openly publish those results. We need independent assessment of impacts. This is about doing things in an open and transparent way for moral reasons, but also practical reasons as well. And then finally, we need governance arrangements to be clear before deployment. So, in conclusion, research into geoengineering is essential as an insurance policy lest we fail to reduce emissions sufficiently. The Royal Society concluded that geoengineering is very likely to be technically possible, but we need to undertake research into both the technical and social aspects of proposed techniques to ascertain which, if any of them, can be employed without countervailing side effects. And I'd just like to end by throwing down the gauntlet a bit. Duncan Wingham, in his talk yesterday, spoke about the need to focus on solutions. And I think that as a community, we're pretty good at focusing on problems. We know about this problem of ocean acidification. We know about the problems of climate change. And really what we're doing is, by working more in defining those problems, we are essentially cataloguing a morgue. We know that we will lose many, many species. For each degree temperature rise, we will lose roughly 10% of the species on this planet. And as was said yesterday, we're well on path for 4-degree temperature rise. So the question is, we know this, we need to work more on the solutions. And so this is from about a century ago, during the Great War, to try and encourage people to sign up. Daddy, what did you do in the Great War? And I think the modern version is, Mum, Dad, what did you do during the great climate crisis? I counted the dead is not a good enough answer. We need to do more than that. We need to develop solutions. We need to investigate those solutions, and we need to work out how to do that. Thank you very much.